Hello, everyone. My name is Stefan. I'm one of the co-founders and the CEO of I-ELCAP. At I-ELCAP, we're assisting radiologists in analyzing medical images. We've done so since 2019, where we were co-founded. Started out in Romania, managed to expand to around 17 countries right now, 300 different deployments. And we have a chest X-ray algorithm and a lung CT algorithm. Lung CT, of course, since this topic of today, does lung nodule detection and also tracking. And having this, we were basically able to be involved in a couple of initiatives that are related to lung cancer. Currently, I-ELCAP is used in the Hungarian cancer screening program that was mentioned here earlier. We are tendering, of course, for the Romanian one that's going to start up. And there's a very interesting one that I'm going to be focusing a bit more today because it's a bit different with incidentary pulmonary nodule detection in a very big hospital in Bucharest. So firstly, I'm just going to walk through the workflows that those programs have. It's interesting, I think, to see in comparison. So the Hungarian one, probably the one that you know about most already. There's a fixed screening center that people get brought to, and then analysis is done on site. But then there's this great second part to it in which there's a mobile unit that basically can go to different places, and this is relevant in terms of allowing different communities to benefit from this sort of services, right? The mobile unit sends data in the same packs, basically in the same database as most of the scans are. So this is very good for having a centralized way to report. The Romanian one is going for a bit of a different approach in which they're going to be using different screening centers throughout the country, spread out throughout the country. And everything is just going to be redirected directly to the National Lung Institute, Pneumology Institute in Bucharest. And while in terms of let's say, simpleness of how this program is going to be implemented, it has some advantages, I think. There might be some potential disadvantages in terms of reaching specific communities that might find it hard to come to participate in the program itself. So these are the more standard, I would say, and those are two of the most standard, and there's probably another model that is fairly standard in how to do it. I'm not going to shift to the project that we're running with the University Hospital of Bucharest, which again this is not lung cancer screening, it's incidental pulmonary nodule detection. And basically the idea is when a patient comes in, most likely emergency room, they do a chest X-ray. If the chest X-ray has any signs of lung nodules, they're going to be sent to a low-dose CT scan where a scan is performed. Fleischner criteria is used in order to assess when the patient should come back for the follow-up. And then they enter in the follow-up loop, right? So they do a follow-up, and lung reds is used to assess severity and the stage of the patient and next steps. This is, again, a bit different. We've been running it for around 1 year now. Some interesting data is that I think out of the patients that come in with chest X-ray and then are sent for the CT scan, around 3% are categorized in the highest category of Fleischner score, and then around 18% more, 17% more are in the second highest category. So around, let's say, 20% of those patients have to take a fairly quick follow-up to the scan. Now, what I want to talk about is things that we've seen working in these programs, specifically this one, and things that we see that are not working from our experience. And in terms of what's working, I think that, of course, I'm going to talk about I-ELCAP, but AI tools today, generally, they fit the radiology workflow very well. So you are able to cover the chest X-ray analysis. You're then able to do lung nodule detection with measurements, fairly precise measurements, and output the relevant criteria, whether Fleischner or BTS or whatever it is. And then you're also able to do the follow-up part with AIs, and now there's been a lot of discussion of big three, calcium scoring and emphysema as well, something that we are also currently adding. So this is one of the things that works well. Another thing that we feel has a lot of progress to it, and it has been one of the main things that we've been focusing on, especially in studies, is in screening populations, you're going to screen different types of populations from a social perspective, right? And it's going to be done in different places of the country. So you're going to start seeing a drop in the performance of the AI algorithms. And we've studied this both on chest X-ray, which is a study which is published already, and on lung CT, which is upcoming. And in both of them, chest X-ray, there's a significant drop, but on lung CT, I'd say the drop is even bigger. In the study that we ran, 6 different countries. What's interesting to see is that simply adding more data doesn't necessarily solve the problem automatically. So you need to be very conscious of the way that you add data in order to solve the problem. And also there's a couple of things, technical things that you can do to help with it. But generally, we see more and more attention given to the generalization problem in this field, which we think is a very good thing. Now, in terms of what didn't work or doesn't work still, I think that in these sort of programs, whether lung cancer screening or incidental pulmonary nodule detection, there's multiple departments that are involved at the end of the day. And the AI tools are very focused towards, very geared towards the radiology part, which I think decreases the efficiency of the program. So this is one of the things that needs to be addressed in a way that the outputs need to be integrated to all the relevant stakeholders in the chain. And then the second thing is, and this is specifically for the pulmonary nodule detection, incidental one, there needs to be an assurance that people come and follow up on their investigation, because otherwise a lot of this efficiency gets dropped. And again, this is something where AI products are not really doing a lot. I think if not developing their own thing for ensuring the follow-up of the patient, at least they should group up with companies that are doing things like this. That was pretty much, those are our lessons and conclusions in terms of working with this field. Thank you very much for listening.